Hello, this is question 6 from the 2016 MAT. 4 people A, B, C, D are performing a dance, holding hands in the arrangement shown above. Each dancer is assigned a 1 or a 0 to determine their steps, and there must always be at least a 1 and a 0 in the group of dancers. Dancers cannot all dance the same kind of steps. Find. A dancer is offbeat if their assigned number plus the numbers assigned to the people holding hands with them is odd. The entire dance is an offbeat dance if every dancer is offbeat. Right, okay, probably have to go through that again. In how many ways can the 4 dancers perform an offbeat dance? Explain your answer. Right, so an offbeat dance. So what was offbeat? An offbeat dance means all dancers are offbeat, which means that their number plus the numbers of those next to them are odd. So we're saying things like A plus B plus C must equal 1 or 3. So we're saying these sort of things. And then, B plus A plus D is 1 or 3, and so on. C plus A plus D is 1 or 3. And whatever the other one is, D plus B plus C is 1 or 3. So we have to have, what did it say? We have to have at least a 1 and a 0 in every group. So let's go with then let A equal 0. So at least we've got 1, 0 in there. So therefore we've got B plus C equals 1. Well, equals 1. It can't equal 3. So we can't have that. So B plus C is equal to 1. So, well, it doesn't matter which one we do. I mean, they're identical to each other because they're both then connected to D. So let's say let B equal to 0, C equals 1, and then say, well, it's symmetry, so doesn't matter which way round. Which way round? So that would then mean that we've got A plus B. That means that D would have to be 1. Therefore, D equals 1. So that satisfies that one. It satisfies that one, but it doesn't satisfy that one or that one. So that means, therefore, let's just go up here, save myself a bit of space. We have got no offbeat dances. Offbeat dances. Right, okay, so let's set that scene. Part 2. Oh, we got a new dance starts. 2 more people join, such that each dancer holds hands with their neighbours to form a ring. Right, so we've now brought in, say, E and F here and here, and we're just doing this ring around the outside, and we're getting rid of these bits in the middle. So we've now got that set up. How many ways can the ring of 6 dancers perform an offbeat dance? Right, so, well, we can start the same way. Let's say let A equal 0. We do that again. So, and then it doesn't matter which one we have with B. So let's say B is 0, F is 1. So that works. So therefore C would have to equal 1. Oh, E. Actually, it's E. Look at the picture. I was just going around in letters. But in the picture that I've drawn, we got E would be equal to 1. Because if we got 0, 0, that's got to be a 1 for B to work as offbeat. That is 1. D would have to be 0. And C would have to be 0. So that actually works. So we'll be going 0, 0, 1, 0, 0, 1. That is an offbeat. So that equals offbeat with, in this case, E, F are both equal to 1. But we could have on this, I suppose, I mean, that's 1. We need opposite pairs to be 1s. So we could have that AC is equal to 1, or we could have that BD is equal to 1. So that leads to 3 permutations. Okie dokie. So, part 3. In a ring of n dancers, explain why an offbeat dance can only occur if n is a multiple of 3. Right, they've led us to this here, haven't they? So how are we going to explain it, though? So it has to be a multiple of 3. So we've got that A1 must be between two zeros. So we've got that. We have to have 0, 1, 0 because otherwise we get all ones, or it wouldn't be offbeat. So, and what we got for a 0? A 0 must be between a 0 and a 1. Otherwise, again, we wouldn't get offbeat. So we must have 0, 1, 0. Then that would have to be a 0. Then that would have to be a 1, which would make that a 0, which would make that a 0, make it a 1. 0, 0, 1. We're going up in blocks of 0, 0, 1. So yeah, we have to have that. So that means, yeah, so just put that in, I suppose, blocks of 0, 0, 1, which leads to it's a multiple of 3. Right, okay, that's taken up a lot of space. Let's go for clean sheet. Part 4, a new dance. A ring of n is greater than 4 dancers. Each holds hands with dancers one person away from them. C hold hands with A and E. Right, okay, let's get this down then. So if we got 5 people on this, so say we had A, B, C, D, E. So that's the smallest ring that we could have. So A would go with C, go with B, E, would go with B. All right, so we're drawing out a star on this. Okay, so we've got that. Now, what does that mean? That's still just a ring, isn't it? I mean, they're just holding hands with 2 people. It doesn't matter that we shuffled the order up, surely. So, I mean, say we rewrote this as, so A is next to C and D, D is next to A and B, B is next to D and E, and C is next to, yeah, so that works. This is just a ring. This is a ring as part, which one did we have? Part 3 or part 2, whichever way we had before, but it's still just a ring. There's nothing clever about this at all. So, I mean, we could have done the same with this one. We could have written this just out as A, B, D, C, and then said, well, A is between those two, C, D is between those two, and we just got that big ring. So that's a ring as per that. And we'd be able to do that every time with these. If it's odd, is it odd always going to come back to the, say we had 7 of them, it's always going to come back to the start, isn't it? C, D, E, F, G. So that would be to there, to there, to there, to there, to there, to there, to there. Yeah. So therefore, n odd means that we need n multiple of 3. What if n was even? So say we had 6, A, B, C, D, E, F. A would go with those 2, C would go, oh, we just got a, oh yeah, we get 2 rings. And we'd have the same if it was, yeah, if n is even, we're going to get that every time, aren't we? Because we're just going 2 round. We'll end up back at A once we've done 1 loop, but we've missed out half of them. That leads to 2 rings. Each will have to be a multiple of 3. Multiple of 3. So we'd end up having to have, does that mean we have to have a multiple of 6? No, it probably doesn't, does it? If each has to be a multiple of 3 and then we're adding them up, well, it would be, wouldn't it? So yeah, that's how it's going to be, isn't it? Because we're going to take the total number and then we're going to halve it, and each one of those halves will be a multiple of 3, so it must be a multiple of 6 because we've got a factor of 2 and a factor of 3 in this. So yeah, for which values of n can the dance be offbeat? Okay, so that's okay. There's more. There is more. On another planet, the alien inhabitants, okay, have 3 arms. Still like to dance according to the above rules. If 4 aliens dance, each holding hands with the other, how many ways can they perform an offbeat dance? Good grief. Right, so we've got 4 of them. A, B, C, and D. Yeah, it doesn't matter the letters. And they're all right, so everyone's holding hands with everyone else. So we've got that set up. So if we had a 0, then that would mean that, let's draw the lines in. That's a 0. Then the others, they've all got to be 1s. Or, so we could have 1, 1, 1. How would that work? So that would make A offbeat. And because that would add up 0. Well, they're all adding up each other. Whatever we do, we're adding up all numbers. So all the numbers have to add up to 3, or they have to add up to 1. Yeah. So A plus B plus C plus D equals 3 or 1. So we could have, well, if it's 3, we got 1, 0, which could be any of them, could be the 0. So that's 4 permutations. And if it's 1, then any one of them could be the 1. So that would also be 4 permutations. So we've got 8 permutations then, all in all. Yeah. Okay. And then the last part, 6 aliens standing in a ring perform a new dance where each alien holds hands with their direct neighbours and the alien opposite. Right, okay, right. So we've got A, B, C, D, E, F. So we've got this ring around the outside, and then we've got this crisscross going on in the middle. So say we add then a 0 for A, which means they could all be 1s that A is attached to. So that could be one option. Or we've got 1, 1. So we could have that. Or we could have, well, it doesn't matter the mirror image of that one. So these are our 3 options, essentially, from A being a 0. So if you had this one here, then the first one, then off of this, we could have, so let's look at this one that we've got there then, which is linking to these 2. So they've either got to both be 0 or both be 1. If they're both 1, then I think we're stuck straight away, aren't we? If they're both 1, then we would have 3, 3. Oh yeah, we get a 4 for this one over here. So we have to have it like that. That works though, doesn't it? I think, because all the 0s are attached to 1s, which gets 3, or all the 1s are attached to 0s, which gets 1. So that works. And it'll have 2 options. So that's the only way we can go there. If we add this middle one, then we'd have, so we've got this setup going on. So this 0 on the side here is attached to a 0. So these have got to be 1, 1 and 1, 0 on these. So we either go 1, 0, which would not work, or we go 0, 1, which would also not work. So that just doesn't work. And then here, if we try and fill in, we would have, so this 0, we could have 0, 1, which is the same problem, that isn't going to work, or we could have 1, 0, which also isn't going to work. So we just got 2 permutations on this one. Fortunately, it doesn't ask for an explanation. So it's just going through the different permutations and actually see what works and just eliminate them one by one. So yeah, not the most exciting of questions, that one. There was quite a lot of it as well. It was just fiddly. It was just going through every option available and seeing which ones worked and which ones didn't.